mystery item.
This here.
They've got a bit of an advantage here because there's some of these over there and they're having a look.
Sure, lift it up.
This one's quite an easy one compared to normal, actually. The answer, if you look really carefully, is there in the picture. The answer comes a bit later normally, and I ask for yes or no, or questions that would get a yes or no response. Any questions about how to identify this mystery, not so mystery object?
Does it have some sort of hat on it?
No, it doesn't.
Oh.
That is the whole thing. That's the thing just taken out of the box, and I soldered the header pins on there, but that is the whole thing.
Oh, sorry, I wasn't looking at the audience video. Wow. Okay.
Yeah.
Okay.
That one, your video, which I can't see.
So I think it's the bottom right, which gives you a big idea.
Oh, sorry, I'll turn my video on. What is it?
Yeah, so what the audience there is the mystery object attached to a board called the Blank Explorer.
I was going to say
breaks inputs and outputs and adds a lot of functionality to the thing.
Very slim.
Okay.
So go on, Andrew.
I was going to say, is it a Raspberry Pi Nano? Pico.
Oh, I nearly got to say no there. But yeah, this is Pi Pico. It's quite clear from that picture, really. But this, normally I go to the speaker for this bit, actually, but maybe I'll just go on to my rabbit hole about what this is. So the Raspberry Pi Pico, it's not a microcomputer, which the rest of the Raspberry Pi family is, cheap PCB-based computers. This is a microcontroller, so very similar to an Arduino, and that's excellent at controlling, getting data from sensors and controlling peripherals like motors, screens, and other things you can connect to it. So it's a bit more, not quite real time, but it's snappier in its activities. So it's not a computer. It doesn't have an HDMI port. You can't necessarily, you can't plug a keyboard and a mouse into it. It doesn't work like the other Raspberry Pis in that computery kind of way. This is focused on controlling kit. Hopefully you can see those. Yep. So yes, it is a Raspberry Pi Pico. It's a microprocessor, but it's better and cheaper than an Arduino, which is remarkable, actually. Here are some prices. So this is the Raspberry Pi family. So we've got the Raspberry Pi 4, which starts at 35 quid, but if you add a bit of memory, it can soon get to £50. We've got the Raspberry Pi Zero, which is still a computer. It's still got an HDMI port, and you can run a desktop on it and check your email and whatnot for just £15. And that comes with Wi-Fi and Bluetooth and that kind of thing. But the Raspberry Pi Pico up here on the right costs £3.90. How is that made for £3.90 in Wales? It's incredible. Yeah. So comparing that to Arduino, I've got an Arduino Nano coming in at just over £12, and that's already 4 times the Pico. And the Pico is technically more performant. It's got a better processor, more. Maybe I'll come into that later. So I'm a huge fan of this Pico, just for that reason. Also, going back to that last slide, I got this from Pimori, which is a pretty common site buying Raspberry Pi stuff. Out of these 8 different Raspberry Pi products, 5 of those are unavailable because of the shortage of parts. they're still making them, but their production runs get snapped up so quickly by their industrial customers mostly that they're just not available. So the Raspberry Pi 400 is one just there, which is a Raspberry Pi in a keyboard, still available. But other than that, you're stuck with the Pico if you're a Raspberry Pi fanboy or girl. So a lot cheaper and more performant. So a bit
Did
about.
you say it's got Wi-Fi? Oh, okay.
Yeah, so there's two versions of the Pico. The original Pico came out in, I think, January 2021, and a new version has just come out, which is a Pico with Wi-Fi as well. So it's a brilliant IoT device, although there are alternatives, which I'll maybe show you later. But just as an overview of the Pico, there's a new ARM processor. This is a Raspberry Pi designed chip that is used for the Pico, but they license it to be used for other devices as well. So there'll be lots of devices using this processor. So it's a dual core ARM, so you can do two things at once. It's a lot faster than Arduino's. It's got a load more flash than Arduino's. It can run off less than 2 volts, so you can get a couple of AA batteries and run this device. And Arduino is a little bit harder to do than that. So that's actually a really useful thing to make it something you could just stick in a box outside somewhere, and it'll last for weeks on its power consumption. It's got 30 general purpose in-out pins, so you could connect it to 30 sensors or 15 sensors and control 15 motors, lots of that kind of stuff. It's got a timer and a real-time clock on board, and this bit bakes my brain a little bit, but it's got 8 programmable input-output state machines. I/O state machines handle the timing important communications with things like screens and other kit that you can connect to it. So like communication over an I2C or SPI bus needs quite precise timings. These state machines, and there are 8 of them on board this less than 4 pounds computer, handles the communications of all of that without you having to do any timing aware, bit banging kind of complicated coding. Yeah, actually, that picture on this slide was from dronebotworkshop.com, and his first foray into this that demonstrates the useful of these PIOs is controlling neopixels. So when you put the power on, apply power to a Pico, it starts doing what it does pretty instantaneously, whereas the other Raspberry Pi products, they are microcomputers, so they have to boot up a BIOS and then load an operating system and then maybe start an application to actually do something. So it takes a good few seconds for that to happen. That's a proper computer. This is a microcontroller that has you program it to do specific tasks, and it just does those as fast as it can. Wonderful. Oh, so these are the connections. There's loads of them. There's 2 hardware serial ports, which that's been a bit of a constraint on projects that I've done before, actually. But the 3 analog to digital converters, 30 digital input outputs, and 2 SPI buses and 2 I2C, or 2 SPI buses or 2 I2C buses, but very capable from a connection point of view. And notice this red box here, the whole thing runs on 3.3 volts. Even if you power it with that 1.8 volts, you still get a 3.3 coming out of it. So it's got a booster in there as well. So yeah, just a very usable, very connectable, very performant device for less than £4. This is the jam, the software bit. So when you get the Pico out of its box, you connect it to a computer with a USB cable whilst pressing a button down, and it comes up like a USB drive, and then you drag a file onto that drive to turn it into a micro Python based Pico, and then so you can code in MicroPython, drag a different type of file on there, and you get a C++ as well. And then you program it as you would any Arduino using an IDE to do that. And you can use the Arduino IDE to code Picos as well. I think you can use Thanet, which is the Python IDE that comes with Raspberry Pis to program it as well. So there's lots of options, and there's even a Scratch-like website sort of thing that you can code to this Pico using a kid-friendly Scratch-like kind of interface. I only found that today and hadn't had to play around it, but that's what this cartoonish-looking interface is. So where you use graphical blocks to get the Pico to do something with maybe things that you connected to it. So it's a pretty new product, but like with all things Raspberry Pi, it comes incredibly well documented straight away, and then there's a huge community that have launched themselves at it and just gone crazy developing all sorts of projects and examples and open source stuff, and just getting really enthusiastic about it.